Now in this video we're going to look at an Excel example of the ANOVA hypothesis testing. Okay, ANOVA again is analysis of variance, and the hypothesis that we're going to test is that all the population means are the same as opposed to at least one being different. In this example we are looking at a general merchandising store where the manager wants to look at ways of increasing sales of the mobile electronics items. So here the manager wants to consider different placement of such items in the store and then see whether that makes a difference in increasing sales. So we have 4 different locations possibilities: the current location, okay, and then we have in aisle is the current location, okay, and then you have the front of the store, a kiosk, and an expert station. So there are 4 different placement possibilities you're considering for mobile electronic items. So you then, to test the comparative effectiveness of these locations, you conduct a 60-day experiment at 20 same-sized stores. And now you randomly assign 5 stores to each of these 4 possible location ideas. Okay, so you make the determination as to which which factor level placement possibility will be assigned to which experimental unit, which is your store. Okay, and then you're collecting sales after 60 days in each of those stores. Okay, and the sample is given here, and we want to test whether the factor here that is different placement of the electronic items is a significant factor in sales. Okay, so let's define the terminologies now. First, let's head on over to the Excel. Okay, now what is the factor, what is the treatments, what are the experimental units, response variable, and the type of study. So these are the basic metadata about the problem. The factor here is the placement of the mobile electronics. So placement location. The treatments are those 4 different possibilities that you're considering. So treatments, by the way, is what? The levels of the factor, different values for the factor. That's your treatment. Okay. The experimental unit is from where you are making the observation. And here it is the stores. The stores are the locations or the subjects from which you make the observation. Okay. The response variable is the 60-day sales. That's what you're measuring. What are you actually measuring? Okay. The type of study here, okay, there are 2 types of studies: observational study as opposed to experimental study. Think observational study, think of you not being able to control. A very good example of that is the GPA study, where students self-select. So that's observational study, as opposed to you assigning the different experimental units to different treatment levels. Okay, so here we are randomly doing that, and therefore it is an experimental study. Okay. Now let's define the different populations. The population, so sales when the placement location is in aisle. Population 2 will be sales when the placement location is front of the store, and then kiosk, and then experiment. So population 2 is front is the placement location, 3 will be for kiosk, and 4 is expert. Now we'll define what mu-sub 1 through mu-sub 4 are, which is mu-sub 1 will be the mean sales when the placement location is in aisle. Mu-sub 2 is mean sales if the front placement is used, and so on. And now we can set up the hypothesis. With all of these different concepts properly defined, then you have the context for what the hypothesis actually means. So hypothesis here is all the 4 different means are all exactly the same. That's your null hypothesis. The alternative is that at least one is different, or you can say not all of them are the same. And let's assume 5% for alpha, and here is our sample data.